Thank you. So we're continuing with the review from yesterday. We left off with the change of base, right? We left off with like if it said log of 5, log base 5 of 2. Okay, so if there's a base in which you can't simplify this without a calculator, there's no number I can raise 5 to make it to become 2, then I would rewrite that as log of 2 over log of 5, and then let the calculator do the work. So it would be log 2 divided by log 5. And I get 0.4306, which rounds to 0.43. We good on those? Yeah. Okay, and then we got into the solving the log equations. So and this was 4, 6, 4, 5. 4, 6 was, 4, 6 started the graphs, and then 4, 7 was the yeah, you're right. All right, so this is 4, 5, and this is where there was kind of like 5 different types of problems. The first was exponential, in which you could change the base to be the same. So if I had something like 27x equals 9x plus 2, something like that. So where the bases could be changed to be the same number. I can rewrite both 27 and 9 as a base of what? 3. So 27 would be 3 to the third raised to the x, and then 9 would be 3 to the second raised to the x plus 2. And then we'd multiply the exponents. So this would be 3 to the 3x equals 3 to the 2x plus 4. Biggest mistake you guys made on this assignment was not distributing the 2 to both. So obviously it wasn't 2 on that assignment. I think it was like 4 or something like that. But you need to make sure that when you raise it to a power, that the power gets multiplied times both of the things that are already there. And then once the bases are the same, so I've got 3 and 3 as the base, then I can simply ignore the bases and just put the exponents equal to each other. So I would take the 3x and set it equal to 2x plus 4. And then solve for x. So subtract the 2x, and x is 4. The directions for these will simply just say solve and check. So the next thing I would do from here is take that 4 and plug it back in and make sure it works. So I would take the 27, raise it to the power of 4, 9, and 4 plus 2, and then let the calculator do the work. 27 to the 4th is going to equal 9 to the 6th. Actually, we plug that in the calculator and get the value to check it.
Did we ever?
Okay, so then the second type of exponential was if the bases couldn't be changed. So if I had 5 to the x equals 2 to the x plus 1, actually this would have been like just 2. Let's start there, okay, and then we'll add to it. So obviously I cannot change 5 to become 2 to a power. So I have to get rid of these exponents. So what's the inverse of exponential? Log. So I'm going to log both sides of the equation, or find the log of both sides of the equation. So I would get log of 5 to the x equals log of 2. And then what do I do with that exponent? Bring it to the front. So this comes here, x times log of 5 would equal log of 2. And then I want to get the x by itself, so I divide both sides by log of 5. Log of 2 divided by log of 5, and I get 0.4306, so 43.
Can you explain why you did log?
So the only way to get, if they're different bases on each side, is you're basically doing the inverse of the exponential function, which is the log. So like if you're multiplying, you would divide, and if you're dividing, you would multiply. If you have an exponent, you would take the log of both sides.
How do you know what the base is?
If the base can't change. The base on the log, you mean?
Wait,
Like-
are you talking about how like they don't?
So these numbers, I can't write one as a power of the other. right? Like, if I had 9 and 27, I can change them so they both have the base of 3. But 5 and 2, I can't do that with.
Okay.
That's the difference.
Could you like just put it into like log form from there, like do like log base 5 2 equals x, and then like put the log thing into the calculator?
Log base, from which one?
Like take it from exponential
Yeah,
into like the log form.
but you'd have to take so you can do log base 5 of 2 equals x, this is what you're saying? Yeah,
And then plug that in.
yeah. Sometimes you've got more than just the x and the exponent. That's the difference. That's the only difference. But yes, absolutely, that works. Okay? So if I had, just make up some numbers and hope that they work. So let's change it to 5 to the 2x plus 1 equals 2. So you can do the same thing if you wanted to, except that on the end you're going to get the 2x plus 1. So you're adding steps to the after part, which is the same. You're going to do it either way. So this, I would log both sides of the equation, and I would get log 5 2x plus 1 equals log of 2. The exponent kicks to the front again. 2x plus 1 times the log of 5 equals log of 2. Divide both sides by log of 5. And I have 2x plus 1 equals log of 2 over log of 5. And then to this, I would subtract the 1, which is going to cancel that out. And at the very end, I would divide by 2. So you can do that in multiple steps in your calculator, but at some point, you're going to have to do all of that. You would end up doing the same kind of a thing if you convert it into log base. So it would be log base 5 of 2 equals 2x plus 1, and then you're going to do the same thing. You would still do you'd have to do the change of base. Yes? All right, so again, you could do it both ways, okay? All right, so then those are all starting out as exponential. The next kind starts with 1 log. So if I have just 1 log on one side of the equation, so let's say something like this, okay? I've got 1 log on one side of my equation. So for these, I need to get them in exponential notation. Think if you have exponential and you want to get rid of the exponential, you do the log. If you have the log and you want to get rid of the log, then you do the exponential. So what's the base on that log? 10. So I can get this into exponential by 10, coming over and picking up the 3, dropping off and leaving the 3x plus 1. If that base was anything other than 10, I would use whatever the base was. So if it was log base 5 of 3x plus 1, then I would do 5 to the third. Okay, you just do whatever it is. So this is 1,000 equals 3x plus 1. And then I would subtract the 1, 999 equals 3x, and then divide by 3. And x is 333. God bless you. And obviously you'll have your calculators, so if you don't know that 10 to the third is 1,000, or if you end up with something like 7 to the third and you don't know that off the top of your head, use your calculator. Figure out what that power is, okay? So that's if I've got 1 log on one side of the equation. Questions on that one? Okay, then we had more than 1 log. Where you have more than 1 log still only on one side of the equation. So these you have to condense, and when we're adding, we do what to condense? Multiply. So this would be log of 3x equals 2, and now I'm exactly where I just was before, 1 log on one side of the equal sign. So I convert this into exponential notation. This would be 10. 10 to the second would equal 3x. 100 would equal 3x. And then I would divide by 3. So Okay, you can leave it as 100/3, or you can change it to 33 1/3 or 33.3. Either, any of those answers would work. Ian?
So, I guess that what you wrote in white, that was like the next one.
I'm sorry, on this could have been that this is a minus instead of a plus. And so you would have done what there?
You understand?
When I condense it, what happens if it's a minus?
Then you would divide.
Good. So I could have gotten log of x over 3 equals 2. Same thing, 10 to the second would equal x over 3. 100 would equal x over 3. And x would equal 300. Okay? So you can have a minus, you can have a plus, just make sure you know how to condense it. You've got to get it down to 1 log before you can get into exponential notation. Questions on that? So if there's more than 1 log on one side. Okay, then you've got where there's 1 log on either side of the equal sign. So if I had log of 3x plus 1 equals log of x plus 3. And this is just like your one-to-one property. If the log and the base on the log are the same and there's 1 on either side of the equal sign, I can ignore the log and the base and just set what's next to it equal to each other.
Nothing is the same.
Correct. And you won't get one in which they wouldn't be the same
So they're all going to be just like,
if there's 1 log on either side.
so it's just 1 to 1.
Yeah, this is 1-to-1. So this would be 2x equals 2 and x equals 1. And remember, you can check each and every one of these. So I can take this 1 and I can plug it in here. And this would be log base 10 of 3 times 1, or 3 plus 1 is 4. And then take it and plug it in here, log base 10 of 1 plus 3, which is 4. So you can always confirm these. Questions on any of the solving of the equations? Okay, let me double check it. Okay, so 4.6 was your introduction into E and ln. So E, remember, E is just a number. E is just like 2.71727 and so on and so forth, okay? It's an irrational number because it doesn't end, okay? And it just has a symbol that's its value. So every time you're seeing E, you're really just seeing 2.7 rounded, okay? And then you had ln, which is the natural log, and that's log base E. So this is the last one that you just did on that Canvas assignment, okay? Where if you have ln of E, then whatever's in your exponent is what your answer would be if I'm simplifying this. Because ln of E becomes log base E of E, and that becomes 1. So if I had ln of E to the 2x, and it asked you to simplify it, what's your answer? 2x. Easy stuff, right?
Do we simplify that? Like the exponent?
Yeah, you probably won't be able to. It'll probably be something just like that. And then the reverse of it would be if I had e to the ln of 5, let's say. Now the reverse of this, again, would be e to the ln. If I put that in exponential notation, that's e to the ln being log base e of ln of e, which is log base e. And they would be 1-to-1, so they cancel out and leave you with just what's next to the ln, which in this case would be 5. The only catch on this is if the e and the ln were not exactly next to each other. So we had one like that on that assignment where it said e to the 2 ln of x. So when the e and the ln are not exactly next to each other, what do you have to do with it? Move it to be the exponent. Good. So this 2 becomes the exponent on the x. So this is e to the ln of x squared. And then the e and the ln cancel. And my answer is x squared. Questions on that one? So keeping it really easy in 4-6. That's pretty much all that you're going to get covered in 4-6. Okay, and then in 4-7 was the graphs of e to the x and ln or log. And so I said it yesterday, but just to reiterate that you're not graphing these, you don't actually have to graph them. You have to either take an equation and describe the transformation, or if I give you information, write the equation, one way or the other. So if I had f of x equals negative 2 ln negative x plus 3 minus 4. Actually, let's do one more. Let's do 1/3 in here. You're probably not going to have all of it in one, but just so you can kind of get it all covered at one point. So what's the negative on the front of the 2 do? Flips it over the x. So this flips it upside down. What's the 2 do? This is a vertical stretch. By 2. So remember, vertical stretch, we don't change. What's the negative inside the parentheses do? Good. This would flip it over the y. What's the 1/3 in front of the x do? Good. This is a horizontal stretch. And it's always the reciprocal, which in this case would be 3. What's the plus 3 do inside the parentheses? Left 3. And the minus 4 on the outside? Down 4. Okay, so you do this one. Same thing, but now it's exponential. So the only thing that would have changed is what the original parent function looked like. Describe the shifts that would be happening. If you had 1/2 times 3 to the x minus 1 plus 4. All right, so who can tell me what's happening on that g to the x equals 1/2 of 3x minus 1 plus 4? What's the 1/2 doing? It's a vertical compression by a half. What's the x plus or x minus 1 doing? So if it's in the exponent, it's like it being in the parentheses. That's what kind of shift? Horizontal. So this is right 1. And then the plus 4 after it is up 4. I'm sorry? The 3 is the base. Yeah, no, the 3 is just telling you it's exponential. So that 3 could be any number. That's your parent function. 3 to the x would be your parent function. It's right 1. You mean horizontal would be if it's a compression, you mean, or a shift?
Compression.
A compression would be inside the parentheses, and it's the reciprocal. So then the last kind is this last one. Write the equation of the function. If you're starting with, if the parent function is f of x equals log of x, and it's reflected over the x-axis, a horizontal compression by half and 4 units up. So what's over the x-axis? Where does that happen? In the parentheses. So this would be a negative, no, just kidding. Over the x, I'm saying over the y. Negative in front. Okay? Compressed by a half horizontally, which means what? It's inside the parentheses, and it's actually 2x, right? You always do the reciprocal. And then 4 units up means plus 4 at the end. So this would be my transformed function, okay? Over the x is out front, over the y would be inside the parentheses. A vertical stretch or compression is in the front and you keep the number. The horizontal is inside and you flip the number. Horizontal shift is inside the parentheses or inside the exponent for exponential, and then a shift up or down is after it. Positive goes up, negative goes down. Everybody good? Questions? You're feeling comfortable? Yes? Okay. So I'm going to give you like the